It's time for AI News, brought to you by AIAW Podcast.
So we have added this kind of section in the middle of the podcast where we just have a short break speaking about some personal favorites, news items that happened in the last couple of weeks. And each one of us can choose to bring up a topic if you have any. If you don't, feel free to ignore. But if you have, try to summarize it in 3-4 minutes if you can. Anyone that wants to go first?
Holy crap, I can go.
Yes, awesome, Stefan.
Super excited. No, I just came back from South Korea and I met with a lot of really interesting people. Yeah. Primarily two things. One in the ability to train models on visual input, video and such, which is super cool. But one thing that really blew my mind is the small language models.
Yeah, awesome. I love it already.
Oh my, I never tried it and I couldn't believe it. This is like the equivalent of me connecting to internet. I was shocked. I downloaded it. I can't get it to run here in Europe, but I ran it in Korea for like a couple of weeks. I downloaded it. It just helped me with my writing, like real time on anything within my operating system.
Remember the name of it? So
from the Upstage team, a little one. So the same one that built Solar model. And
so the idea with a small transformer is actually I can put it inside my laptop and I can run it in real time.
It runs all the time. And whenever you write something, it's there.
In real time, more or less.
Yeah.
And this is for me how it should work.
No, but
flipping back and forth.
No, but I didn't want to believe it. I had to even go turn off my Wi-Fi, even check that it didn't sneak out on my Wi-Fi in some weird way. It's like I didn't want to believe it because it was so magical. It was insane.
Was it like auto-completing or was it really like writing?
So I started to, I used it in different ways, but the classical kind of, you start writing something and then that little icon come up and then poof. And then you have like formal, informal, you can like auto-prompt it in some way, shorter, longer, use emojis, use not emojis, meaning that it takes whatever you write and then give you a suggestion how you can actually write it better.
Of the existing text so far?
Of the text that I started to write. So it has a little bit of an input and on that input, it's like auto-completed-ish and styled it up into formal, informal and these kind of things. So think of to like Grammarly, but real time. In everything, everywhere. And I'm like, I don't know. You know, I've wrote in my kind of predictions for 2024 about small models and how excited I was.
As well, actually, so
and then I was like trying it and I was like, I couldn't even predict how excited I was. Sorry, I just like get all like a kid here. The organ is going to come back. Vacuum organ.
I think that's one of the big trends for 2024, that we will have more efficient models. And that is going to democratize, if you can abuse that word a bit, to basically have any person.
And this is all that Gemini did the storyline with the huge, the normal and the small.
Yeah, the nano one. I think it's
the nano one, they call it.
No, but and also I run it on my old MacBook.
It makes sense.
Yeah, I run it on my old M1 MacBook. So it's not of the super new ones. It's not, I mean, this is several years. I don't even know how old it is. But it worked like a charm. And I'm meaning that's going to be in every single thing. Yeah. More or less.
To be everywhere.
So all of a sudden now you get to embed a language model inside a product of some kind.
Equally as big as internet, I would argue. And I think now it's
much more.
Yeah. I'm trying to be nice here. About internet, there's people here in the internet watching us.
Okay, so that's good news.
Alex, do you have anything that you want to bring up? No. Okay. Good.
I was thinking we're going to go back to that topic about bring your parents.
Actually, that was the news.
That was the exactly.
That was the news topic that we can now bring into this, because if we're cutting it, there was an Instagram. There was a storyline around recruitment in US.
Yes.
Tell us the news, because this is news because it's
again
3 times.
It's enough now.
All right.
He has forgotten.
All right.
Goran will cut it back in.
Do you want to go next?
Yeah, sure. There's a lot of stuff happening, and it was actually a number of weeks since we had the last podcast now over the Christmas holidays and whatnot. So it's hard to choose what to really pick up on. But the one I chose is actually something that I have mixed feelings about. It's called AlphaGeometry, and it's from DeepMind. And it combines this kind of traditional rule engines or symbolic engines with more language models. So In this case, it's in a competition, a math competition called the International Mathematical Olympiad. And it basically became as good as the gold medalist, or between the silver and gold medalist of the best humans ever competing in this kind of math Olympiad. And it's in geometry kind of math type of tests. But of course, super impressive. What's new really in this one is it's not really the combination of having both rules or symbolic systems combined with neural network kind of solutions. That's been done a lot in this kind of hybrid system. But what's new is they use language models to do the creative part. So when they describe a bit what humans do is, okay, they can, use deductive rules to try to see how can I prove that this kind of geometry has X and Y property, and that they know the rules. The problem is that the thing that humans are really good at is coming up with rabbits, as they call it.
Yeah.
So the rabbit is this kind of weird thing, what if we add this kind of variable to the equation? And it comes from nothing. I mean, it doesn't really make sense. So you just have some kind of creative inspiration of what happens if we do this. And that is a really hard thing to do, especially for a computer, because it doesn't have any sense on why should you add this specific thing. So some kind of intuition is guiding humans in finding solutions for these kind of math problems. Now, what they were able to do better than anyone before was use large language models to do the creative part of pulling the rabbit out of the hat. I would say that they are basically taking the problem that a lot of people see with large language models, which is hallucination, that they just make up things that looks good, but actually using that as a feature.
Yeah.
So suddenly the ability for large language models to make up stuff becomes useful because it's still related. It's based on some kind of intuition that you can't really describe. It's just that, okay, let's add this in the language of math in this case. And suddenly they first try to do is just with rules. They may fail finding a solution. Then they ask the language model, please add a construct or a new rabbit. And then they try again and it may not work. And you try a second and a third time. And then by adding a number of constructs, suddenly it finds a solution. It solves the problem. It finds the proof. And this kind of combination of using neural networks, large language models, to be the creative, hallucinating kind of part of humans, combined with the very deductive, logical kind of rule engine, is very fascinating, I think.
Yeah.
So this kind of creative part of being able to come up with strange things that you don't really have a reason for, intuition in some way, and you can call it hallucination if you want, is turning out to be really useful.
And what is the usefulness? Is it creating new ideas on this, or why is this useful?
I mean, they just use it to show that an AI model is as good as humans, more or less. But of course, in future,
creative thought.
But I think,
in finding proofs for math problems. So
okay.
In the future, if you have another problem, let's say you want to solve one of the biggest problems of all, how you can combine quantum mechanics with relativity, we haven't been able to do so. But perhaps if we have a sufficiently intelligent AI system that can start to add constructs and rabbits, perhaps we will find a solution.
Yeah, because the point is that you're not going to solve the new problem with old thought. So you need to be creative in some sense to combine things, to be creative. Is that?
Yeah, I mean, I think to take humans are not logical. I would say that 90% of human thought. I heard someone else. I think it was my PhD supervisor said that 90% of the human kind of reasoning is abductive. Abductive meaning it's not deductive, saying, if something is certain from a logical point of view. Abductive means basically you haven't proven it's wrong. You just make an assumption. I think a car will fly into this room. Prove me wrong. Or I think God exists. Prove me wrong. It's abductive kind of reasoning. And this is really what they are doing in this model is abductive reasoning. It's not deductive. So they're combining abductive with deductive reasoning, and the marriage between the two makes it possible to find mathematical proofs in a way we've never seen before.
So in a nutshell, abductive and deductive,
Yeah.
And this is one of the ways forward for next generation level mathematical problem solving as an
Any
example.
problems with the physical world that we have, for the economical world we have, for
But
the medical
those
world
complex
we have,
problems
kind
that
of-
you need to be you need to find new ways to think about how to solve them because humans has not solved them yet.
Yeah.
Yeah.
Humans
Yeah.
are too stupid to solve some problem.
Yeah.
We need
No, but
AI to
I think it's also
interesting.
maybe the structure. I remember we talked about it last time I was here because I just wrote a piece on creativity in that sense and how I tried to formulate it into a differential equation, meaning if I can understand it so I can write it as some sort of equation or formula, then I understand it on a scalable level. One of those I mentioned an old thing that really blow my mind. There was this old kind of folded, I don't know if you remember this, it's a protein folding game, fold.it. So it was for super nerd. This is before we have cloud computing, meaning that the biggest problem you have to solve if you have hard computing problems is where to compute on, meaning we have local clusters on universities and these things. Some of us are nodding and having good memories or painful memories maybe. But one thing that I found also interesting with this case is that, you can sign up for this if you have a university account. You get a protein folding sequence. They're trying to solve the HIV problem, right? The scientific community have tried for 10 years solving this, solved 35%. All of a sudden, you get these small packages, they fold. Somebody has a stupid idea from another department, maybe in this case, the mathematical department or some other sec. Why aren't you trying this? This is not how we do protein folding. We all know how it would sound, right?
I need to be more creative. By the way, Alex, you had to leave at past, right? Or what was it?
No, go on.
Okay. Otherwise, we need to focus a bit more before you have to leave on your kind of favorite
No,
topics.
it's all right. It's all
Okay.
right.
The list is long.
Awesome.
Henrik,
I mean, I'm gonna go with the example topic I mentioned to you. I mean, and I'm completely out of depth here, but I want to talk about it.
Completely out of depth.
Yeah, because I'm moving into his territory.
Okay, now I get it. I was like, what?
So I stumbled upon a paper by Google Research came out, I think Tuesday, January 23rd. It's this week, and it's about the Exphormer. So sparse transformers for graphs. So this is a paper that sort of indicates and gives design patterns for architecture for how you build transformers that are more sparse. And what does that mean? It means sort of how do you work in the whole transformer in a way that you don't really need to light up the whole neural network sort of thing. So it's expanded graphs, and it's about being way more efficient with compute and with energy and everything like that in order to find the right result. So I think the theme here, which I think is a trend, is how do we build more things more efficient, and what are we talking about when we say sparse transformers and stuff like this. So I'm going to lean a little bit into you, Anders, here now, but I think the trend here is a little bit interesting. We started with the Mixtral, mixed experts type.
I want to read about it quickly.
and I haven't read the article, so I'm reading right now. And I'm trying to
But don't be an expert. You don't need to be an expert. But I just find the interesting trend here.
Yeah.
We are trying to figure out how to not light up the whole neural network. Is the bottom line.
Yeah, and I haven't read the article, so I can't say anything smart about it. But I can at least give some kind of context, perhaps. And we know transformers have really transformed, pun intended, so much of the AI that we have, being able to use, sequences like words or even images in a way that we never seen before. So with the additional attention that they have in knowing what to focus on, they have really revolutionized how we can use AI. Now, to use it on sequences or images is one thing, but the most general kind of data structure you have is a graph in some way. A graph with nodes and vertices that you can connect to each other. And how can you use a transformer network then for graphs? That's a hard problem. When we sparse graphs, it basically means you have very few connections. In a social network, you have a few friends, but if you take 3 steps out of yourself, it's very few of the people that are connected to each other. So it's very sparse, and that becomes hard to represent. So they need to have a way to represent these kind of sparse networks and graphs in a good way. And I'm guessing, without having read the paper, that that's something that this can do.
So the bottom line of the paper is that when you have a sparse network and you're trying to do exactly that, it's actually not that many nodes happening in reality. But because this transformer doesn't know that, he needs to go over the whole fucking Facebook before he can realize that, that was just fucking 3 nodes. And now with the Exphormer, they're trying to figure out to circumvent that. So basically not going through the whole Facebook graph in order to find something that was quite easy to find because your network was in reality quite sparse. Yeah. Which is, if you think about it, lighting up every single person in Facebook in order to check, do you know Henrik? Rather than doing it in another way. It's about efficiency here. I think these kind of, the way I pick something out of my head competence-wise, but I think it's a trend. With the mixed expert approaches, with the nano approaches, with the sparse network approaches, this is a major trend for 2024 around efficiency and smartness. So we're going to see, what is GPT-5? What's it going to be? Is it going to be more bigger? Is it going to be a mixed expert? What are the driving forces? One of the driving trends is efficiency, so we can use it in different ways, embedded and stuff like this. This is my sort of take.
I think it's a way to use transformers efficiently for a new structure, which is graphs. There's been other times, Robert Luciani loves graphs,
Yeah, he had this story.
He's been using transformers for that.
Actually, I was gonna ask Robert, because he used graph and transformer to solve traveling salesman's NP problem, and he had an idea, and he's been proving it, but no one understands what he did 2 years ago. And I think now we're getting
proving it.
I don't know.
I haven't still seen any.
Mathematically, he was claiming he could. He had his.
He could prove it. He didn't prove it.
I don't know. But he
claimed he could prove it. That's not proving it.
No, I was in a business meeting together with Robert with the guys at AI research at Volkswagen, talking about it's an optimization problem in the transport ecosystem. They didn't get it. Yeah. But in reality, like what he did is, thinking about transformers in a GNN and combining that smartly. And I think this is kind of going in this direction, I guess.